Hi everyone, welcome back to Solve It with Arash. I'm very excited because in this video we're going to explore a very important concept in math, composition of functions. This is a powerful tool that allows us to combine two or more functions, leading to new insights about how functions interact. I will start with an example. We will go through the steps together, like how we literally combine two functions and what are the domain and range of the resulting function. Then we will give you an example to try on your own to practice your new knowledge. Now with no further ado, let's jump in. Let's just start with the basics. If we have the two functions f of x and g of x, then f of g of x is the composition of these two functions, where we apply g of x first, and then we apply f on the result. We can also show this as f of g of x, where O is the composition operator. So f of g of x and f of g of x, they will be used interchangeably. We can also have g of f of x, and that's also shown as g of f or g at f. It's very interesting that we can also apply the composition functions on a function itself as well, like f of x, which can be shown as f of x, or g of x can be shown as g of x. Let's look at an example together. If f of x is x minus 1 and g is x squared plus 3, and I want to find the composition of f of g of x or f of g of x, I can write g of x with its expression. So I'm going to have f of x squared plus 3. Then in f of x, which is x minus 1, instead of x, I'm going to have x squared plus 3. So basically, this is going to change to x squared plus 3 minus 1, which equals to x squared plus 2. If I want to find g of f of x, I can write it as g of x minus 1. That gives me x minus 1 squared plus 3. And this is equal to x squared minus 2x plus 1 plus 3, which is equal to x squared minus 2x plus 4. Alright, these are the basics. Questions can get more complicated. We also are interested in the domain and range of the function composition. So let's move on to the next slide where we're going to solve another example. In this example, f of x is 14 minus x squared and g of x is the square root of x minus 2. So in the first part, I want to evaluate f of g at 7. So this is basically f at square root of x minus 2, where x is 7. So it's f of square root of 7 minus 2, which is reduced to f of square root of 5. Now in f of x, I just need to replace x with the square root of 5. That means 14 minus the square root 5 squared, which is reduced to 14 minus 5, and that's a 9. In the second part, I want to evaluate g of f of negative 1 and g of f of 4. So let's just start with the first one, g at f of negative 1. So in f, I replace x with negative 1. That will give me 14 minus negative 1 squared, which is 14 minus 1, and that's a 13. So I just need to evaluate g at 13, which equals to square root of 13 minus 2, and that's the square root of 11. All right, the next one is g at f of 4. So let's continue down here. And first thing, I need to evaluate f at 4. That's 14 minus 4 squared. So g at 14 minus 4 squared, which is equal to g at 14 minus 16. That's a negative 2. Now I need to evaluate g at negative 2, which means square root of negative 2 minus 2. That's a square root of negative 4. But wait a second, we can't have negative values inside the square root. So this is undefined. All right, for the same f and g functions, I want to find f of g of x and define its domain and range. Okay, so let's evaluate, or let's find f of g of x. And I'm going to show it with f of g this time. Again, it's totally fine if you want to go with f of g or f of g. You can use them interchangeably, as I said earlier. Now, f of g is going to be f of square root of x minus 2. Now we have 14 minus square root of x minus 2 squared. That's equal to 14 minus x minus 2, which equals to 14 minus x plus 2. The final expression is going to look like 16 minus x. So this is f of g, but I also need to find the restrictions, because I know g of x is the first function to apply, and it has some restrictions. For g of x, we know under the square root we need to have a non-negative value, so x minus 2 has to be greater than or equal 0, therefore x must be greater than or equal 2. That's the start point. That's the domain of g. We can't have a number less than 2 as an input for g. And then we find the output of g of x and give it as an input to f of x. The final domain is going to be a subset of the domain of g of x, because g of x, the domain of it's the start point, and we know that x has to be greater than or equal to 2, right? So that's the start point. But once we input it to f of x, there's no further restrictions. And I can say that x greater than or equal to is basically the domain of f of g. You can also show it as square bracket 2, comma, infinity. And now that I have the final expression for f of g, which is 16 minus x, I can also draw a graph for it. That also helps me to find the range and domain. Well, domain, we already figured it out, but let's see how the graph looks like and what is the range of the function. I know how to graph this function, 16 minus x. It's a straight line with a slope of -1 and the y-intercept of 16. So let's assume this point is 0 and 16. And then the slope of -1, something like this. It goes down with the slope of -1. So this is the line of 16 minus x. But we know that x has to be greater than or equal to 2, meaning starting from here, go up, and this is the start point, and anything after that in the positive direction. So going this way, I make it a solid line. But before this point, it's a dashed line, which means it's not in the domain and range of the function. And you can also figure out where the y value of the start point is by just replacing x with 2, because this is 2. Then f of g at 2 equals 16 minus 2, which is equal to 14. That means this point is basically 2, comma 14. And this 0 and 16, that goes to the y-intercept, which doesn't exist in the graph of the function. The function is basically this solid line starting from this solid circle, and the solid circle, it means this is included in the domain and range. This point is part of the acceptable points for f of g. Let's go to the last part where we want to find g of f of x. So I first apply f of x, which is 14 minus x squared. Then I will apply g on the result. That means the square root of 14 minus x squared minus 2, which can be reduced to 12 minus x squared. To find the domain of the function g of f, I start from the domain of f, which is inside the brackets. So domain of f is all real numbers, because f of x is basically the function of a parabola and there's no restrictions on the domain. But I need to make sure that the output of f will produce a positive value under the square root, because the output of f minus 2 is going to go under the square root. So the output minus 2, which is 12 minus x squared, has to be greater than or equal 0, which means x squared to be less than or equal 12, and that means x to be between square root of 12 negative sign and less than positive square root of 12. The square root of 12 can be rewritten as 2 square root of 3. So x has to be between negative 2 root 3 and positive 2 root 3. What about the output of GOF? Okay, now that I have the expression for GOF, I can write it as y equals the square root of 12 minus x squared. And I know the output of square root is greater than or equals 0. So I know y has to be greater than or equals 0. Now I raise the two sides of the equation to power 2. That gives me y squared equals 12 minus x squared. Let's rearrange this equation and write it as x squared plus y squared equals 12, knowing that y is greater than or equals 0. X squared plus y squared equals 12 is the equation of a circle where the radius is the square root of 12 and the center is at the origin. So if I want to graph this function quickly, it's going to look like a circle, and I'm going to show it with dashed line for now. The center is at the origin, and the radius of this function or of this circle is square root of 12. This is not a function at the moment because it fails the vertical line test. So let's just call it the circle. So on the far right, this point is at 2 root 3. On the leftmost, we have negative 2 root 3. The top, we have 2 root 3. At the bottom, we have negative 2 root 3. Now, we also know that y has to be greater than or equals 0. So we can ignore the part of the graph which is below the x-axis, and we just include the part of the graph which is above the x-axis. So this is basically a semicircle. Okay, and this also shows me the domain and range. As you can see, the domain is between negative 2 root 3 and 2 root 3. So that's the domain. And in terms of range, y value is from 0 inclusively all the way to 2 root 3 inclusively. So range is going to be y values, real numbers between 0 and 2 root 3 inclusively. And as I said, this is the domain. Now we have the domain and range of GOF. We also have the expression for GOF, which is the square root of 12 minus x squared. Now it's your turn. In this question, we have f of x equals 9 minus x squared and g of x equals square root of x. In the first part, evaluate f of g of 3, then find g of f of 0 and g of f of 4. And part C and D, you're asked to find f of g and g of f and their domain and range respectively. Find your answers, leave them in the comments, and I'll get back to you with the feedback. That's it for today's video. I hope you enjoyed it, and don't forget to leave your answers to the challenge question. I'll get back to you with a constructive feedback. And if you enjoyed this video, don't forget to like, subscribe, and share with your friends. Until the next video, keep solving those math problems.